Everyone, and welcome to this learning video on generating function. So dear learner, let us see what is meant by a generating function. So generating function of the sequence of an infinite sequence of an infinite sequence an, or sometimes we denote by ak as well, of real numbers of real numbers a1, a2 up to ak is denoted and defined as, so it is denoted by g of x and it is defined as summation ak x to the power k, where k takes the value from 0 to infinity. So generating function is nothing but an infinite sequence of real numbers of the form summation from k equal to 0 to infinity ak x to the power k. Here ak is nothing but the general term of the sequence. That is, in general we call it as the kth term of the sequence. So the closed form and how to obtain a generating function for a given function we'll discuss in the next lecture. Right now we'll concentrate on how to solve a recurrence relation using generating function. For this, one should have the knowledge of the generating function of some special functions. So these are the generating function of some special function. Here this is nothing but the general term of the sequence, which we denote generally by ak, and if general term of the sequence is ak, then whatever its corresponding generating function is denoted here by g of x. So say for example, if we have a general term of the sequence as 1, then its corresponding generating function will be nothing but 1 upon 1 minus x. Then if we have the general term of the sequence of the form a raised to k, then its generating function is 1 upon 1 minus x. Of course, a is a constant term. Then b into a to the power k, where a to the power k is the general term of the sequence, where b is a constant. So in that case, what we do? We simply multiply the generating function of a to the power k by b. Hence, its generating function is b upon 1 minus x. Likewise, if the general term is k plus 1, then its generating function is 1 upon 1 minus x whole square. So here I have listed out all the useful generating function for a given general terms. So this one is expected to remember if we wish to solve the recurrence relation using generating function. So let us start with the first problem on solving the recurrence relation using generating function. So let's start with the first problem. So solve the recurrence relation, which is given as an is equal to 3 times an minus 1 plus 2, with the condition given as a not equal to 1. So first of all, here we'll find out the least augmented term. So here least augmented term is n minus 1. So in order to apply the condition a0, we have to find out the value of n. So to make it a0, what should be value of n? It should be 1. Hence, we will have to multiply this recurrence relation by x to the power n, and then further summation will take the value from 1 to infinity. So I repeat, the lowest augmented term is n minus 1. So n minus 1 will become 0 when we have n is equal to 1. So therefore, in order to get the solution of this recurrence relation using generating function, we'll multiply this by x raised to n on both the side, and summation will take the value from 1 to infinity. So let's start with. So let us assume that g of x is equal to summation n is equal to 0 to infinity of an or ak. Here it is, since the suffix n is used, so we will write n, or otherwise we have seen that k can be also be used in place of n. So an x to the power n, where g of x is the generating function, g of x is the generating function for the sequence. What is the sequence here? Sequence is an. So what we do? We multiply, let us call this recurrence relation as 1. So multiplying equation 1 by x to the power n on both the side, and taking the sum, and taking the sum or summation from 1 to infinity, we get. So what do we get? So it's a summation an will multiply by x to the power n. So an x to the power n, and summation will take the value from 1 to infinity, is equal to 3 being a constant. Take it outside, it will come out of the summation. Remember, sum runs only over the values which contains n. So summation, then an minus 1 x to the power n is equal to 1 to infinity, plus 2 times summation, 2 comes outside, then what is left? We'll multiply this by x raised to n, so x raised to n, summation from 1 to infinity. This is how it is done. Now after this, what we'll do? We'll just apply the sum here. So it will be a1, put very first value to be substituted for n is 1. So a1 x plus a2 x square and so on. Then equal to 3 times. Now when I substitute n equal to 1 here, it will become 1 minus 1, 0. So a0 x power 1 plus a1, what it will be? X to power 2. Next we put n as 2. So this will be 2 minus 1. So a1 x power 2 and so on, plus 2 times. Now it is a summation of x raised to n. So here the general term over here, the general term over here is nothing but 1. So that is one way. Or what is the another way? Another way is just apply the sum. Put n equal to 1. So we have x plus x square plus and so on. Now what we do? The generating function starts from a0, then plus a1x plus a2x and so on. So remember here, whatever will be the suffix of this a, same should be power of x. So a1x is there, but the generating function starts with a0, right? So what do we do? So here a0 is missing. So we will add a0 here. So it is a0 plus a1x plus a2x square and so on. As a0 is added, so it should be subtracted also to balance the term, is equal to 3. Again here what we see, the suffix of a0. So there need not be any term of x. So what we do? We have to take x common. We have to take x common. So when we take x common, what we have? A0, then plus a1x and so on. Now, so this is as per requirement. A0 plus a1x. So we did not have to add or subtract some extra terms. Plus 2 times. Now, this is the standard series and it's a geometric series. And geometric series always starts with 1. So let's take x common. So what do we have? We have 1 plus x square and so on. Likewise it is done. Now if you see this a0 plus a1x plus a2x square, this is nothing but g of x as per our notation, and a0. So here we'll have to substitute the value of a0. So what do we have here? So substituting the given value initial condition and replacing a0 plus a1x plus a2x square by g of x. So we have here it is g of x minus a0 then equal to what do we have? 3x then g of x equal to 3x into g of x plus it is 2 times x we have taken common, and the rest of the term is nothing but the geometric series 1 plus x square. This is an infinite geometric series. Infinite geometric series. Now here we will substitute the value of a0. So it is g of x. A0 is nothing but given as 1 equal to 3x g of x plus 2x, and then what we find here, the formula for infinite geometric series is first term 1 upon 1 minus a upon 1 minus r. A is nothing but first term over here in this geometric series is 1, and the common ratio is x. So as per the formula we have a is 1 upon 1 minus r is x. So this is what we have here. Now after substituting all the initial condition and using the standard formulae, let us collect the term of g of x. So we have g of x, shifting this term on the left hand side and taking g of x common. So it is 1 minus 3 of x. Now is equal to, shift all the remaining term on right hand side. So we have 2x upon 1 minus x plus 1. Now simplifying this right hand side expression, so it will be 2x plus 1 minus x upon 1 minus x. So we have x plus 1 upon 1 minus x, which we can further write as, now here once we get now after this we'll obtain g of x. So this is nothing but g of x into 1 minus 3x. Now we have to obtain only g of x on left hand side. So dividing by 1 minus 3x. So before this you can see here we can separate the numerator. We can separate the numerator. So what do we get? We get this as, or let us divide. So x plus 1 upon, we have 1 minus x into 1 minus 3x. So this is what is the expression for g of x. Now after this we have to express this right hand side in such a way that one of the formula in this useful generating function can be applied easily. It means we have to either obtain the denominator in the form 1 minus ax or 1 minus x whole square, or it is 1 minus x whole cube likewise. So we have to express this in this form. So for this we will apply the partial fraction method to the right hand side. So consider right hand side and apply partial fraction method. So it is 1 plus x upon 1 minus x into 1 minus 3x. Make sure that the linear term should be either in the form 1 minus x or 1 minus ax. So here we have 1 minus x as well as 1 minus 3x. So we can directly apply partial fraction. So as per this, it is a upon 1 minus x plus b upon 1 minus 3x. Now next task is to find out the value of a and b by partial fraction. So we have 1 plus x equal to, simply cross multiply. So a into 1 minus 3x plus b into 1 minus x. Collecting the like power of x. So let's collect the constant a plus b, and then term of x will be x common. So what is left? Minus 3a, and here it is minus b. So we have 1 plus x equal to this. Now equating coefficient constant and coefficient of x. Coefficient of x. We get a plus b equal to 1 and minus 3a minus b by equating coefficient of x is equal to what we have? It is 1. So in this way, we are getting the two equations. Solving above two equations simultaneously to get the value of a and b. So above two equation simultaneously we get, you can use calculator as well. So we have the value of a as nothing but minus 1, whereas the value of b is equal to 2. So we will substitute this here in this expression. Now this is required in this equation of, so let us call it as equation 1, 2, and this as 3. So we will substitute these values of a and b in equation 3. So substituting, therefore equation 3 implies 1 plus x upon 1 minus x into 1 minus 3x is equal to 2 upon 1 minus 3x minus 1 upon 1 minus x. So therefore this is to be used on equation 2. Equation 2 you can see here. So therefore 2 implies g of x is equal to 2 upon 1 minus 3x minus 1 upon 1 minus x. Now you can see here we are getting the form wherein I can use this formula directly to obtain what is the general term of the sequence. So 2 upon 1 minus 3x. 1 minus 3x is in this form and 2 upon. So here what is the value of b? B is nothing but 2, whereas what is the value of a? 3. So as per this third formula, we can have this as 2 times what? A is 3. So 3 raised to n minus 1 upon 1 minus x. This is 1 upon 1 minus x. So that's its general term is nothing but 1. So this. Now, what is the general term of g of x? So, general term of g of x is nothing but an. So, this way we have obtained the solution of generating function. What was our task? The task is to solve this equation, that is to obtain an. So, here you have to see what is the lowest augmented term. Now, lowest augmented term is n minus 1. So, make it 0. For that, n should be 1. This is the reason why summation starts from n equal to 1 to infinity. Then, apply the sum. After this, make sure you will have the term of the form a0 plus a1x plus a2x like that. So, accordingly, you have to add or subtract the required term, or you will have to take the common term. Once we get this, then you have to apply the standard formulae. They collect the term of g of x. Then you will get the expression wherein we have to apply the partial fraction method. We have already studied about the partial fraction method. Apply your method of solving this expression, get the value of a and b, and then we have the form wherein we can use this standard formula. So using this standard formula, you will get the required solution. So I hope this is clear to all. In the next video lecture, we shall see few more important examples. Till then, thank you for watching the video.